Today, having done the general element drawing yesterday, we hope to take a step further um, in giving a structural solution to a structure. Like I had introduced to us yesterday, is to first relate with what exactly have been passed on to your decks by the architect or by whoever it is had worked before you. All right, so you want to look into the solution as touching stability, safety, and economy. All right, and that will lead to the generation of a general element drawing like done yesterday. And I believe that we have clearly stated in terms how to go about these things, and that made us arrive at this junction that we are. All right, so that's simply. In case you were not here yesterday or you'd like to go over again to see how we did our stuff yesterday, it's available on my channel at Joshua the Designer on YouTube. Uploaded earlier today. So you just use that video for your benefit. All right. So to start with today, we want to take a step further, like I said, to begin to use product structure. And product structure is a structural design software which, like I said yesterday, is commonly used now, and people, structural designers and engineers, have started adopting that in designing their reinforced concrete and even steel structures. All right. So, and in these 3 days tutorial training, we are going to take certain steps, and at the end of the 3 days we are sure that you as a beginner or an intermediate um, designer should be able to do one or two things as structural design. So nobody should be a novice after this time out. Nobody should be um, an alien to certain things when it comes to structural design after this contact. All right, so having done this general element drawing, which signifies or will represents the layout for our structural components and how they are being positioned, their sizes, and all of that. So we want to bring in these details that we have already worked on, and this detail is in alignment with our what I call it now architecture. All right, so let's do a little revision on what we did yesterday by superimposing these things on architecture to be sure that we are good to go. Then begin with product structure. All right, so I told us yesterday that we are supposed to block our drawings so that we'll be able to write on the architecture and it won't give us a mess when we're doing so. You can name them as you will. All right, so let me check my first floor and superimpose on the first floor here. Now, there is something that is hidden to us yesterday, and not that it was hidden, it wasn't hidden, we didn't pay attention to it, and it's clearly shown here. If you discover at this point, our frame ended on grid line E. This is grid line E. Our frame ended on grid line E, which patterns along the ground floor walls on grid line E. But when we get to the first floor, you see that there's an extension to your bedroom on that floor. It means that that slab or that beam would have to extend up to that point to cover for that as a support. Right. So that's one of those things you will discover as you begin to compare your GA with another. All right. So that can be a cantilever. You do not need to worry. Okay, so that's clear enough. Now I can replace this now with this. that I've corrected. All right, so now that we are done, let's just go ahead with our product structure. Then I'll show you certain things. All right, I really want you to pay attention tonight because tonight we'll be done with modeling this structure completely. We are going to probably analyze the structure. Then tomorrow we would look into some other things as touching designs while we wrap up. All right. So these are the GA. These are the general element drawings. So we want to take them into product structure. And if you have a product structure in your system, we have to load. Now this is the home screen of product structure. So if I want to begin my work on product structure, I can use the new project button. Now it will demand that I enter a project code and you may put whatever name, Nicesa, or you can put my project. Then the templates here represent the codes. Of course, you know, many of us are in school, we use different codes of practice, and this is vary to regions, all right? But we in our own region we use the British standard, all right? That's the BS code, all right? Some adopt the Euro code, right? Some use the American code. Yes. So there are different kind of codes of prices. Like you can see, we have the Brazil, we have the Hong Kong, we have the Indonesia island, Malaysia, and all of that. A lot of them. So but we use UK 8110. If you are using UK Euro code, you can apply that. But let's stay with 8110 for this class. That's if you want to use a template. But if you have a job you have done previously and you have adopted a code in that job and you want to use that code in this new project, instead of picking the code afresh, you can go to the project where you have used the code earlier, then search for which of the project, click it, and press OK. But because I am dealing with us as though this is going to be our first issue of product structure, we are using 8110, and then we press OK. This automatically opens a new template for so that you can do your job. All right, so but because we have our general element drawings available before now, we can just import these drawings to product structure, then we begin to work on them. So how do we import? How do we import? Now we import as external reference drawing, and the external reference drawing has to be a DXF file. A DXF file. So it means that what I've done on AutoCAD, I need to convert to DXF file. So I have to go back to AutoCAD. These are my general image drawing. So because I really want to get the whole thing clear, I will just have to copy this arrangement to a new template. Then I paste there. Then I can save as a DXF file. So you use save as here. Then you can name it anything. I can name it my project. Then you come here, change to a DXF file, then save. Oh, do I know where exactly I saved? I didn't check where I saved the project. Alright, now I've done that. So when you're done, you can close it. Yes. Now I've closed my DXF file. Then I get back to my product structure. I use the external reference drawing. Once you click the external reference drawing, you can add the drawing here. This button will help you add the drawing. So you now have to locate the point where you saved the job. The point where you saved the job. So this is the project, my project. So I can press OK. So it has automatically loaded the project that I saved. Then you can activate this. Now you see that on the background something activated as pictures, right? So after doing that, I can press OK. There's actually a way to import your elements straight up, like import the columns, import grid lines and all of that. Because this is a beginner class, so to say, I want to take us step after step. All right. So I have the GA, the one I've done on AutoCAD. I have them here now on product structure. So I can follow what I've done on AutoCAD here on product structure. So the first thing I want to do now, because my grid lines are not active, even though like I said, there's a way we make our grid lines active directly on product structure. If you want to know about that, on my channel I have how to import drawings to product structure. You can use that as an alternative means if that's complicated. So that's my that. So let's begin to put our grid lines. Now you click this is the grid lines under modeling. Click grid, a box opens for you. Now we have names for our grid already. So this starts with A. So this is going to be my grid A. You have to hold down the control button so that it becomes straight. The next one is grid line B. So you come to label, edit to B. You drop it. Come to the next one is B1. Come to B1 and drop it. Alright. In fact, I should name that B2, not B1, because I have one before that. I have this, a short one, B1. Then the next one would be C. The next one will be D. The next one will be E. And the last one, F. So I'm done with the vertical grid lines. So let's check for the horizontal grid lines. Still grid 1. 2. Then I have the next one, 2A. Next one, 3. The next one, 3A. Next one, 3B. Alright, so we have 4A. We have 5. We have 5A. We have 5B also. We have 6 and we have 7. Alright, so our grid lines are complete right here. And what we need to do next is to begin to insert our columns. So to do that, we have an idea of where our column positions are already. We can just begin to insert them. So this is a column, and the sizes are 2 to 5 by 2 to 5. So we can begin to put them in. If you are not sure of their location, you can confirm again from your drawing on AutoCAD so that you'll be very, very sure of what you're doing. All right. So from here, let's look to it. We'll have 3 at this point at intersections. You see that intersections, we'll have one here, one here, then let's see what happens there. We have one here and one here at that point. Another one at this point. We have another one at this point. Still 2 to 5 by 2 to 5. So let's first deal with all the 2 to 5 columns that we have. I have one here, I have one here, I have one here, and I have one here. Alright, I think I'm correct. We have one here and we have one here. I'm going to share the drawing with us probably after tonight's contact so that I think we had demand for that yesterday. I could have just done that. I couldn't. Okay, we have one here also. So that is all for 2 to 5 by 2. Then we have two 450, this one and this 450 by 450 column. Then we now have the circular column. So that's going to be 450 here. To edit that, just change this to 450, or you change the second one rather, 450. But you notice that when you insert it, the eccentricity needs to be visited. So that means we have to do something on the eccentricity on this side by using 112.5. You see that by putting minus 112.5 at the eccentricity, it shifts the column downward. If you use plus 112.5, it shifts the column upward. So that's the usefulness of this eccentricity. Alright, that's for this side. Then for the second one, the same thing happens. I have that. So all my columns for the first floor have been fixed. Alright, so we have another column here. We have another column here. Let's not forget that. We have a column here. Alright, so we can do the beams now. Let's do the beams now. No, but there's something we've not done because there is supposed to be a specified height for each story. So you want to specify what height exactly applies to your stories. So by right clicking story here, you have edit story. By the time you click edit story, you see that you only have one story here, but we have two stories to deal with. The story one is the first floor and story two is the roof. Alright, so that means we have to create one more story. So how do you do that? Right click again, then insert story. So the total number of story will be 2. Then you can do OK. Yes. Alright. Going back to that place still, let's edit story now. We can, so that we won't get confused, we can name this first story first floor. In the description, you can name it first floor. Then the second one, you can name it roof. That's all right. Then the height of each floor, we want to maintain 3150. Let's try 3150. Then the other 3150 for each floor. That's okay. We are good. Now let's deal with the beams now. So this is the beam, RC beam. Once you click your beam, you have a box like this. We're using a 225 by 450 beam, and that's why I'm entering this value here. Alright, so if you want to do that, this is the beginning of this continuous beam and the end of the continuous beam. You see, now this is where the primary and secondary beams come in. If I had drawn this beam first, I'll be making an error because it's not the primary beam. So I have to pay attention. You have to pay attention to that also. Now I can't draw this first because at this point is a point load and not a support. So it can't come first. So I have to hold on and draw this first continuously. So while I drill that first, I can now put my point load on that span to come here. I hope somebody is getting what I'm saying. Now this one also can be a point load on both span. Alright. And this one also can come through like this. A point load here as a continuous. You get what I'm saying? I believe somebody can hear what I'm saying.
Following.
Yes, sir, we are with you.
Alright. So
Yes, we can hear you, sir.
when we do this, this one comes here. This one also goes here. Alright. So Alright, so we have this. Now you have a question here. It says new beams crossing over other beams. Do you want to split the new beam at supporting span? It's telling to you that do you want to support this new beam that you have drawn with other beams that are present? That is, do you want it to become a secondary beam? That's what it's saying. So once we did like that, it means that at this point, that beam will be a point load at this point. At this point also it will be a point load. That's what it's saying. So you have to understand that as a structural designer. Know the responses, know the effects and consequences of things that you're doing. So this also is a point load. This is a simply supported beam. Alright, this one can come straight up to this point. This one comes straight up to this point. It is important that I drill this one and this one first because those two will be responsible for the support of this new beam. So you have to pay attention to that. There's a reason I'm emphasizing on that because it can cause great failure. And this is a software. There are some softwares that are garbage in, garbage out. Either you do the correct thing or you do the wrong thing. Its program is that it must give you an answer. It must give you a result. So if you do the wrong thing, you get the result. If you do the right thing, you get the result. So don't do the wrong thing and kill people while they are sleeping in their house. Alright. We have some circular columns here. Let's fix them. Let's see what diameter they represent so that we can fix them accordingly. So 375. So that will be 187.5 in radius, if I'm correct. 187.5, yes. Alright, so let's do that. Column. So that will be 187.5. This is the center of the column now. The diameter, sorry, is 375. Update. Alright, we have that. The same thing happened here. Okay, we still need a grid line on this part. Alright, so let's fix that grid line quickly. So I'll call that B prime and not G. I'll call it B prime and not G. Alright, so the reason why we need to put that grid line is so that we can insert our columns because without insertion point you can't do that. Oh, but that grid line is not straight. It's not straight. I just saw that. B prime. So we have here and this here. All right, so we are left with the slabs now. Let's just fix the slab also and see how it looks. So clicking on the slab here, you have a pop-up box. The thickness of your slab, let's use 150 mm. All right, and the cover to reinforcement for a slab is 20 mm. All right, then for the loads, we have dead load and live load constituted on a slab. All right, so for the dead load, for rooms, if you are using the dead load for rooms, normally if you want to input this load manually for yourself, we use finishes 1.2 and partition 1.5. So it becomes 2.7 in all. But product structure had helped in its own way to have factors for various occupancy or use. So for flat roof, there's a factor 1.0. For room, it has 2.375. Terrace or balcony 3.175 and all of that. So, but if you are designing for a room, it says 2.375. But if I have to put it manually, I'll put 2.7 because 1.2 finishes 1.5 partition and that will work. For impose load, if you right click into that box, into this box, there are different factors on this. If you check my last two videos on my channel, while I was saying how to design a cantilever slab, I showed a text from Reynolds. I showed a page from Reynolds textbook speaking about load, the life load factors, which is a function of occupancy. There you will see various number of them, and also you can see something like that here. You know, this shows different kind of occupancies or use. Now I'm designing this building is a residential building, and that's why I can pick either general domestic use or residential communal area with limited use or bedroom and dormitory. But the one that fits in very well is general domestic use. All right, so that's for my life load 1.5 kilonewton per meter. I can begin to insert my slabs. Okay, so at this point there is no slab because there is a roof here. That's why we have our roof. If you remember yesterday when I told you about the lower roof on the first floor, that's why we have that roof. So we are done with the first floor. This is how the first floor looks. Now we import three GAs together. Let's now do the roof GA, the roof arrangement. Then we'll see how it looks in 3D, and we can begin some other settings. Now I want to move this GA to be in alignment with where we are working because this roof is supposed to sit on the first floor. So we want to move that to that place to see how we can proceed. Okay, so I'll go back to my building setout, external reference drawing. I want to move this GA over this one, and I've done that. So I've moved, this is the one we did just now. So, but I've moved the the roof over this one. Now I'm done with the first floor. Now I want to do the roof. Now I have to go to story 2, which is the roof. Then back to the external reference drawing. I'm dealing with story 2 now. Okay, so you see where we are now. Did we get that, or I just confused somebody?
Come again, sir. Come again.
All right,
We are confused.
story 1 is the one we just did now. And we used this external reference drawing while it was on story one. So that's why we had this picture on story one. But now that we are going to story two, we need to go back to external reference drawing to shift our GA to story two. Then we'll press OK. So you discover that you see it on story one no more, but now it's on story two that you see it. That's what I've just done. Is it clear now? Not clear still.
Start from the move.
Okay, I should start from move, Abby. All right.
Yes.
There is a function here, move. If what we did now, this is on first floor. Let me go back to first floor. Let me start again so that we get it. So now there is this function move. So I can move this first floor over another floor. So when I move it, it will shift. Did you see? It has shifted to the middle. I can also shift it again such that this one will be over this one that I've just done because I need it to trace out my beams and some other elements. You see now? So I've moved it again. But now what I want to do now is that I need the roof GA to be able to trace out my components on the roof floor. So when I get to the second story now, I need the roof GA on this one so that I will know where my columns are and where my beams are. So that's exactly what I need now. I hope you got that clear now. Alright, so I'll just put story 2 because that's where I need it now. And I have OK. Now you see that it has appeared. The GL has appeared now. So what I need now is my columns and to fix my walls and my beams. Now there are two ways. It's either I begin to insert my columns manually, just as we have done previously, or I can generate all that I've done before. If they are the same thing, I can generate all the elements to this floor if they are the same thing. So let's see. Let's generate the elements to this floor and see if they are the same thing. Now you can come to this story, right click, generate story. I have some details on the first floor. I don't want to generate slab. I don't want to generate slab since it's roof I'm dealing with. I don't want to do anything with slabs. It's only my column and beams that I want to generate to story 2. And I press OK. Yes. Then I close. Now you see now, instead of drawing afresh, my elements have appeared. Just that we have new elements and we have some to remove. So let's visit those things that we have to remove and those things that we do not want. This column, I think, let's now check our normal GA if we are still on course. Alright, this column is not starting on this floor. So this column is off. This column is off. We can do away with this beam since we are on the roof now. We're on the roof now. We don't need this beam primarily doesn't need to come, but this one can go all through. This one can come on. This one also can come out. Yes. Alright, so I believe we are fine with that. And this guy can go. We don't need this guy at this level. He can go. This one also can go. We don't need this one at this level because that's the roof. That's the area of the roof. Let's see what we are. Okay, so we are good now. We are good now. Right. Let's now see what it looks like in 3D now that we have modeled everything here. By the time I right click on view, I can see a 3D physical model. I believe you can still hear me.
Yes. Yes, yes, we can hear you.
Yes, sir. Yes, we can.
All right.
Yes, we can hear you.
Please. All right. So let's see how it looks like in 3D. Now, there is something we have not done. This column isn't there. There's something we have not done. These freestanding columns at the roof level, they're supposed to have beams connecting them together. These freestanding columns at the roof level, they are supposed to have beams connecting them together. So this is what I mean. Let's get to the plan.
Yes, sir, please, how did you get to the 3D, sir?
Okay, we are going to do it. I'm coming back there. So we can model a beam that connects from here to this place. Then this gets to this place, and it connects to this place. That's on the roof. Now this is where I got the 3D. Come to views, right click, then select 3D physical model. It gets you the 3D. So this is what we have. Now let's see in comparison with our architecture. Look at this man's building, front elevation, the approach view. Right. So this is where the first floor, the roof of the first floor, which covers the master bedroom, this is where it is, and the entire roof is on this point. All right. So these freestanding columns, they are being tied together at this roof, since they don't have columns at any level before the roof, and that's exactly what we have done. What we have done here. All right. So simple. Now the next thing we want to do is to find our roof load on the beams to I mean beam wall load or block wall load on the beams. So let's get to the first floor and begin to insert the wall load. I really hope you are catching what I'm doing.
Yes, sir.
All right. So let's remove the drawing and get to the first floor. Now this is first floor now. Now the beam wall load is done this way. Did you see what I did now? Let me go back. Right click on any span of the beam. You see different options, but you come here, edit wall load, click it. You have this. The unit weight of a 9 inches block wall is 2.87. The height of the wall we are dealing with, the floor to floor height we input the last time is 3150. So what you have to do now is to subtract the beam above the floor from 3150, because your wall is going to be under the roof beam. It's going to get to the roof under the roof beam. 3150 minus 450 or whatever it is you make the roof beam as. Alright, so that's 2.7. Alright, but I want to make my roof beam 300. I don't want to make it 450. So I want to change 2.85. It will be 2.85. Then the wall thickness is 225. So that's okay. Now I want to, it's not the only one that has wall. I want to put it all round. So I don't want to do it little by little. You can copy this one and paste it all over. Just right click, copy wall load, then right click and paste copied wall load. You see that? So all of them are the wall load now. Now let's see what it becomes in 3D. Now you see now all the walls are there. All the walls are there. I hope somebody is seeing it now.
Yes, sir. Please, how about walls that did not pass through the beams? I just went on
Yeah,
the slabs.
if walls that do not pass through the beams, that pass through
Yes,
the slab,
yes.
those are that's exactly why we use partition. You know, I spoke about partition 1.5 millimeter per meter. In the design of your slab, we cater for partition. So those are walls that are partition walls and not main walls that are supporting
Okay, all right.
beams. So that's
Thank you,
how we
sir.
use partition.
All right, sir.
All right. So I want to lessen the roof beams, the sizes to 300. So instead of doing one after another, I can come here, right click, properties, then when you find 450, you can edit them to be 300. So automatically everything changes to 300 beam. All right. So we're done with that, just to say. All right. So what I want to do next is to edit my materials and to select the reinforcement that I want to use before I go onto my design or analysis. So what you do now is under the analysis, you find building analysis. If you click building analysis, you find building and the project parameters. So if you want to find any now this foundation now, there's always the allowable stress of the soil. So this is a product of what the geotechnical investigation says. So the geotechnical engineer would have done his own enterprise and it will result to give him a soil bearing capacity. So for usually for a good soil, for a firm soil, for part foundation, you should be around 120, 150, and usually it used to be in that range. So let's keep it as 150 for this class. All right, because we are going to be designing part foundation tonight. All right, that's okay. We can edit material here. So for our concrete columns, I want to use a C20 grade of concrete. C20 grade of concrete means 1:2:4. That's C20. All right. And I'm using that all through. For reinforcement for my column, I want to use Y16 and maybe Y20. For my walls, I want to use, I don't have a wall actually, but let's just keep Y10 and Y12. For slab, I want to use Y12. For my links, I want to use Y10. All right, I think I'm done. We don't have steel components here, so
What about the beams? Beams.
beams. Have we done beams? All right, beams. The beams, thank you very much. You're going to have 16, 20, 25. For this job, I don't think we should have more than 16. At most 20. So we're done. Okay. The next thing I'm going to go to is loading combinations. Once you select loading combination, you see that there are no loading combination for your job. So you won't be able to design this until you find the loading combinations to design with. But we have a loading generator. So you can generate a loading for you and the load cases. So once you click this, press OK, it generates for you automatically. Then you can use OK button. We are done. We can now come to analysis. Do a building model check to see if you are alright, if your building model is alright and free from errors. So currently our building model is free from error. Number of error is 0. So you should work towards achieving number of error to be 0. So we are done. You can close that once you are done. Then you can begin your building analysis. Click the column, we are designing beam, we are reselecting bars, and we can start. All right, so you just need to have a little patience till building analysis is done. I believe you all are catching what I'm doing, and nobody's confused.
Yes, sir. We are catching up, sir.
All right.
I have some questions, sir.
Okay, please go ahead.
Can you recommend any practical textbooks, probably for manual design?
For manual design, yes, a lot of them.
Yes,
I
yes, yes, yes.
have mostly I'm Bongi. We have Chanakya. We have our usual Oyenuga also. We have yes, I think those are I think straightforward for you to begin with manual design. Reynolds will help you with some basic details.
All right, sir. All right, is there a manual for this Prota structure? Like, is there a manual for it?
A manual, no. If you need a manual, my channel is a manual.
All right, sir.
I have a question too.
Please go ahead.
All right, I noticed you selected you select bar. Would that not affect the bar that we specify before now?
Please,
Because I
I
remember
cannot hear you.
for the column, you selected Y16 and Y20, also for beam. But now, in the long run, while running the analysis, I noticed there is a box that you check that says reselect bar. In the process of designing, will you not reselect the bar?
No, 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 no. That reselect bar is not for reselecting what we did in the previous place.
All
That
right,
reselect
all
bar
right.
means that if you previously have some bars in your design, in your analysis, like after the final design process, if you have some bars that are not adequate, we can reselect them to be adequate. That's the main point.
All right. Thank you so much. Please, I have another question. I don't know if I can go ahead and ask.
Go ahead, please.
Okay, I notice each time I use this proton structure, you always over reinforce. I will notice that the reinforcement is just too much. Is there any way I can adjust my settings,
You
or
said
is there anything wrong?
uh,
I notice proton structure normally do over reinforcement.
not always, because the design
Eh,
principle for product structure is that it fixes the support and free the span. Instead of having, for example, instead of having WL square over 8 and the midspan, you most probably have, or you most likely have WL square over 11 over 10 and the midspan. Then you have WL square over 12 and the support. Right. So that's the code for which product structure has been written, such that there is fixity at support.
Hello, I have a question. Hello.
So that sums up to all these discrepancies you are seeing. Not that it's over reinforcing. No, it's not.
all right, thank you so much.
All right. I had somebody say something. So we are done with the design process. Eh?
Yes, I have a question, please.
You can close. All right. Speak up, please. Let me hear you.
Yes, my question is, please, I'm just joining the event for the first time, please. I don't know if I can still watch this video again, please.
The video will be available on YouTube tomorrow by then.
Okay. Thank you.
All right.
Okay, sir. My question.
Our design process is complete and our building analysis also is correct. Let's now check our results and see if we are fine. So for columns, check results, you get to your post analysis. Then click column and wall. Now you see that all my elements has passed. All the column has passed. The reinforcement adopted is 4y16, 6y16 for the circular columns, and 6y16 450 by 25. So we're good to go. For my column, everything has passed. Let me check the beams and see. For the beams, all has passed also. See now, everything has passed. So I've designed sufficiently for everything needed. All right, so to go for our foundation,
Please, how did you check again?
all right, there are two ways you can check. Come to your analysis, building analysis, building analysis, then post analysis. Column design, you see all your columns. Close that. Beam design, you see all your beams. That's the number one way. Another way you can check is to come to your design. Then you find columns. Clicking columns, you have all your columns at this point. Going back to that design, let me clean this one. Going back to that design, clicking story beams, you have story. Those are the two ways. All right, so let's design our foundation, and that will be all for tonight. And tomorrow we'll continue from there. All right, so the foundation floor is the story O. This is where you have all your column points to be supported by a pad base. So you can rightly highlight all your columns this way. Right click, you'll see insert pad footing. Once you click that, it goes to the design studio where you are going to run your design. All right, so this is where you find it. You can design all, everything at once. So let's do that. Design all. So it begins to load the process here. You can see the process here. Loading the process here. So we are done with the design. We are done with the design. So the recommended sizes for our base is 1 meter by 1 meter, 1 meter by meter. We see 1 2 by 1 3, 1 meter by 1 meter, 1 2 by 1 3, and all of that. So it has sufficiently designed all the bases, and the reinforcement we have here is Y20 at 250. You see, but why would I use Y20 at 250 for this kind of small structure? Why would I use Y20? Why would I even use Y60? Why can't I stay at Y12? So I can go and edit that right now. So let's go and edit. You know where we did the editing, building analysis, edit material, right? Foundation floor. When you come to foundation floor, rebar diameter. So what I want to select here is Y12. Okay, okay. Then I close. Now let's design again. Insert pad footing. So it's still loading. So we can design all. So we can design all. So still waiting for the design process. Because the design status here has not marked that the design is good. So let's check individually. Let's see what's going on. Says the design has failed. Definitely, there's a problem with the analysis here. So we need to check back what's the issue, because it's not passing no more. It's not passing anymore. All right, so let's check if we have any other issue. Why it's not passing? Okay, we don't have issue with this one. Let me run my analysis again to be sure. Now, but this time I'm not reselecting bars for these guys because they have passed. I just want to use this analysis to correct my foundation. So those are the things you need to know as we are proceeding. Know where to troubleshoot your issues whenever it arises. All right. So we have done that. Let's get back to our foundation to see what's going on. Insert pad footing. All right. Design all. There's something wrong with this base because what is put in there is 5y0. So it's practically not seeing any reinforcement there. Let's check rebars. Y12. You see what I did there? So this is where you design it. Y12. Do you know why it's going back to 12? Because Y12 is not sufficient. Y12 is not sufficient. So I will need to go back and touch my selection and make sure that I have something like Y16 in the stuff. Rebar. So let me add Y16. All right. You should pass now. In fact, some have passed already without even running the analysis again. So, so just design all. So everything has passed now using Y16. All right. So this is okay. Let's see. So all my bases have been fixed. Now, if you're going to see the 3D now, you discover that you have something like this. And my building have been well designed. No issues from any point. You see that now.
Yes, sir, is there going to be a ground beam or is no there's
No,
no
no,
need?
this is a pad foundation. I said the other time, this is a pad foundation. If we are designing for raft, that's when we'll have a ground beam. I believe you know the difference between raft and pad foundation.
Yes, sir.
Yeah. So when we're designing for raft foundation, that's when we're going to have a ground beam. But for pad, we do not need to.
But but I've seen a part before that had ground beams later on that were connecting the footing or the columns from the pad at the top.
The column, the beams were not on the ground. It cannot be on the ground. Were they on the
Uh,
ground?
I
no, it
think
wasn't on the ground.
the beam is always at the maybe where we have DPC, something like that.
Yes,
You see
yes,
that one?
yes. That's the one I know of. It's always around the DPC. And
So, sir, do we also design that and as well there's
you see,
oversight concrete, you know?
no, no, no.
Okay.
You
You
don't
know,
need to.
most of the time
Yes, I'm with you.
most of the time we do have